Three capacitors, 4 microfarads, 6 microfarads, and 12 microfarads are connected to a 12-volt battery. So in part A, draw a circuit diagram and determine the voltage across and the charge on each of the three capacitors if they're connected in series. So the circuit diagram, you have the battery, and then three capacitors in series. I could just do something like this. Just three capacitors in a row directly after each other and then back to the battery. The battery is 12 volts and the capacitors, which I'm going to call C1, C2, and C3, are 4 microfarads, 6 microfarads, and 12 microfarads. I could have also drawn the circuit like this and put a capacitor up here, and then that's in series with the capacitor over here, and then that's in series with the capacitor down here, and then back to the battery. That's the exact same thing. As long as you have one continuous loop that have the three capacitors end to end to end, and then back to the battery, it counts as a series circuit. So with these problems, it helps to draw the QCV chart. We'll start by just listing the three capacitors. C1 was 4 microfarads, C2 was 6 microfarads, and C3 was 12 microfarads. The total capacitance, when they're in series, you have to do the inverses of the three. So it's going to be 1 over C in series is equal to 1 over C1 plus 1 over C2 plus 1 over C3. That's going to be 1 over, and I'm just going to keep all these in microfarads, so the final answer is also going to be in microfarads. We have 1 over 4 plus 1 over 6 plus 1 over 12. The common denominator is 12, so that's going to be 3 over 12 plus 2 over 12 plus 1 over 12, which is 6 over 12, and that simplifies to 1/2. So 1 over CS is equal to 1 over 2, so if I take the reciprocal of that, that means that CS, the equivalent capacitance of all three in series, is equal to 2 microfarads. So I can record that in the total capacitance of the circuit. Capacitors in series have the same charge on them. So the charge, the Q, is equal to the equivalent capacitance of all of them in series times the voltage across, the total voltage across all three of them. The equivalent capacitance is 2 times 10 to the negative 6, 2 microfarads, times the voltage across all of them is 12, and that gives you 24 times 10 to the negative 6 coulombs, or 24 microcoulombs. So I can put that for the total charge across the three in series, which is the same as the individual charge for each one of those, 24 microcoulombs for all of them. And the final thing I can do is calculate the voltages using the equation Q equals C times V. So the voltage across capacitor 1 is equal to Q1 over C1. That's going to be 24 microcoulombs, so I'll just put the micro, divided by C1, which is 4 microfarads, so again just the micro, so they cancel out, and that leaves you with 6 volts, which I can record in the chart. And then V2 is equal to Q2 over C2, that is 24 microcoulombs again, divided by 6 microfarads. The micros cancel out, and you're left with 4 volts, which I can put in the chart. And the V3 is Q3 over C3, which is 24 microcoulombs divided by 12 microfarads, and that's equal to 2 volts. And the total voltage in the circuit adds together, so 6 plus 4 plus 2 is 12 volts, which is what it should be, since that was the voltage of. For part B, with the same 3 capacitors, this time draw a circuit diagram and determine the voltage and the charge for each of the capacitors if they're connected in parallel. So the circuit diagram would look like you have the battery, and then you have a capacitor, and beside it you have another capacitor, and beside it you have another capacitor. So the battery is 12 volts. The capacitors are C1, which is 4 microfarads, C2, which is 6 microfarads, and C3, 12 microfarads. So once again, it'll be helpful to draw a QCV chart. So we'll label the 3 capacitors. C1 was 4 microfarads, C2 is 6 microfarads, and C3 is 12 microfarads. And the equivalent capacitance of the entire circuit, this is an easy one, because for capacitors in parallel, they just add together. C1 plus C2 plus C3. So adding those together, 4 plus 6 plus 12 is an equivalent capacitance of 22 microfarads, which I'll put in the total. Since these capacitors are in parallel, they all have the same voltage across them. So the voltage across the battery is the same as the voltage across C1, C2, and C3. So we can go ahead and put all those voltages down as well. So 12 volts, 12 volts, 12 volts, and 12 volts, which means it's just a simple calculation to get to the charge on each capacitor. So using the equation Q is equal to C times V, I can say Q1 is equal to C1 V1, which is 4, we'll say 4 times 10 to the negative 6 times 12, which is equal to 48 times 10 to the negative 6, or 48 microcoulombs for capacitor 1. For Q2, which is C2 times V2, it is 6 times 10 to the negative 6 times 12, which gives you 72 times 10 to the negative 6, or 72 microcoulombs. And Q3, which is C3V3, is equal to 12 times 10 to the negative 6 times 12 volts, which is 144 microcoulombs. The total charge, which you can get by either doing the C total times the V total, or just by adding the 3 charges together, is 264 microcoulombs. And for part C, draw a circuit diagram and determine the voltage and the charge for the 3 capacitors if the 2 larger capacitors are in series with each other, and that combination is in parallel with the smaller capacitor. So the circuit diagram, you have the battery, you have 2 capacitors in series, so that's going to be one right after the other, and that loops back to the battery, and then those are in parallel with the 3rd capacitor, so that one's next to it. So we have the smaller capacitor is the one in parallel, so this is going to be the C1, which is 4 microfarads, and then the C2 of 6 microfarads and the C3 of 12 microfarads. And then the battery was 12 volts. So we'll put on we'll draw the QCV chart, and we'll label what we know so far, which is that the C1 is 4 microfarads, C2 is 6 microfarads, and C3 is 12 microfarads, and the total voltage applied to the whole circuit is 12 volts. So we need to figure out the equivalent capacitance. So let's just focus right now on these two in series. And, with two in series, it adds like resistors in parallel. When you just have two, you can use the shortcut formula, which is C series is equal to, in this case, it'll be the products of the two capacitors, C2 and C3, over the sum of the two capacitances, C2 plus C3. So that's equal to 6 microfarads times 12 microfarads divided by 6 plus 12 microfarads, which is equal to 72 divided by 18, which is 4 microfarads. So that's the equivalent of those two in series. And now we'll take that and put it in parallel with this other one, and capacitors in parallel just add together. So the equivalent capacitance of the whole circuit is just going to be the 4 microfarads plus the 4, or 8 microfarads, which I'll put in the chart. Now that we've got the equivalent capacitance of the whole circuit, we have two of the three things in the bottom row, so we can solve for the total charge. So Q total is equal to, Q is equal to C times V, so it's the equivalent capacitance times the total voltage, which is 8 microfarads, or 8 times 10 to the negative 6, times 12, which is 96 times 10 to the negative 6, or 96 microcoulombs. So that is the total charge. Another thing we can fill in this table is the voltage across capacitor C1, because this capacitor is in parallel with these capacitors, and so that means the voltage across the battery is the same as the voltage across C2 and C3 combined, which is the voltage across just C1. So C1 has a voltage of 12 volts, and that means now that we can solve for the charge on capacitor 1. So Q1 equals C1 V1, which is 4 times 10 to the negative 6 farads, times 12, which is 48 times 10 to the negative 6, or 48 microcoulombs of charge. So I can put that right there. So if there are 48 microcoulombs of charge on that capacitor, that means there are also 48 microcoulombs of charge on each of the other capacitors, because C2 and C3 have an equivalent capacitance between them of 4 microcoulombs, which matches the 4 microcoulombs of this capacitor. So we can say the charge on 2 and 3 is equal to the capacitance of 2 and 3 combined times the voltage across 2 and 3, which is the same exact equation as above, 4 times 10 to the negative 6 times 12, which is 48 microcoulombs. Since those are in series, it doesn't mean that the 48 microcoulombs is split between them. It means you actually have 48 microcoulombs on each of those capacitors. And that means you can now figure out the voltage across capacitor 2 and capacitor 3 using Q2 over C2, which is Q2 is 48 microcoulombs divided by C2, which is 6 microfarads. The micro part will cancel out and leave you with 8 volts. And V3 is equal to Q3 over C3, which is 48 microcoulombs divided by 12 microfarads, which is 4 volts. And that makes sense because those two voltages should add up to 12 volts.